Okay, let us discuss this problem, finding the tension. So this is rotation chapter, you see. So there is a rod, and this rod is suspended through 2 points. So this point is A and this point is B. So this is a rod. This point of suspension, they are calling it O. This point is point A, this point is point B. So a rod is suspended through two strings, equal strings. A strings with angle theta, this angle is also theta. Length of strings are equal, so this string and this strings are equal. Now the mass of the rod is L. The length of the rod is L and the mass is M. So length and mass of the rod is given to you. Now if somebody cuts this rod, so the question asks, if somebody cuts this rod OB, so if somebody cuts this rod OB, what is the tension in OA? So I have to find the tension in OA when somebody cuts the rod OB. So simple. So what you have to do is, how will you do this problem? You have to write down the equation of motion. So what will happen if you cut this rod? Now free body diagram I can make. This will look something like this. At the moment, just at the moment of cutting, it will look something like this. So this is O, this is A, this is B, and our rod OA, a string OA has been cut. Are you getting? Now you see, let us discuss what are the forces that is acting. So you will have a force that is acting is tension T, because it will a string direction, it will act in the direction of a string. Another force that is acting, that will have mg. Any other external force that will act? No any other external force. Now what will happen to this rod? Let us say what is the component of tension. In this direction, this angle is theta. So in this direction, component of tension is T cos theta. In this direction you have T cos theta. This means in this direction you have a component T sin theta. Now let us discuss. So there is a force on this rod in this direction. So rod will have a tendency to move in this direction. So let us say acceleration in this direction is AX. Because rod will have a tendency to move in this direction, because there is external force, that is T cos theta acting. So let us say at the time when this rod is cut, this string is cut, this has an acceleration in this direction is AX. Now the center of mass also has a force in the vertical direction, mg minus T sin theta, so it will also move in the vertical direction. Let us say acceleration in the vertical direction is AY. Now if you see, there is a also torque. If you see about the center of mass, there is a torque. T sin theta will make a torque. So this distance is L by 2. So T sin theta into L by 2 is a torque. So there will be acceleration about this point also. So let us say angular acceleration is alpha. So we have equations AX, AY. So what are the equations we can write? So let us take 1 minute. And you have to generate 3 equations. You have to write 2 translational equation and 1 rotational equation. Let me see how many of you are able to write the equation. I think all of you can write. Let us write down the equation first and then we'll go further. Okay, let us discuss. So if I write in the x direction, so x direction I have t cos theta is equals to mass into acceleration. So this is equation 1. Equation 2, in the vertical direction forces acting are mg minus t sin theta is equals to ma by, this is equation 2. And if you take torque about center of mass, so this torque t sin theta into L by 2. So if I take torque about the center of mass, t sin theta into L by 2, and this force is passing through the center of mass, so this will not generate a torque. Mg is also passing through the center of mass, so it will also not generate a torque. So t sin theta into L by 2 is equals to I about the center of mass is ml square by 12. Everybody knows I alpha. So now this is the third equation. Now the important part of this question is we have 4 unknown. We have unknown ax, ay, alpha and t. So we have t, ax, ay and alpha as unknown. But now we have only 3 equations. We need one more equation. And one more equation I will get from constraint. What is the constraint is? If you see this point of the rod, so let me make something again. I think you have written. So if you see this rod, so this point of rod, so this is my rod, this is my point of suspension. So this point of rod cannot move in this direction. It cannot move. If it moves in this direction, what will happen? The length of a string is fixed, but if it starts moving in this direction, then a string will slack or a string will break. If it is moving in this direction, a string will slack. Are you getting it also? Either it moves in this direction, a string will break. If it moves in this direction, a string will basically slack. So it cannot move in the direction of a string. So this means in the direction of a string, velocity is 0 and acceleration of 0. That is the radial direction you see. It can move in the tangential direction. It can move in the tangent to this one. Because if it is move in this direction, length of a string does not change. It can move in a circular path. It can move in a tangential direction because keeping the same length. So let me make here. Keeping the same length, you can have this circle. You can also have this circle. So if it comes here, you can have this circle. Keeping the same length, you can have this circle. So length in all cases is same. So here length is L. Here also length is L. Here also length is L. So it can move in the tangential direction. This means it can move something like this. But it cannot move in the direction of a string. So you can write the point A cannot move in the direction of a string. So this is point A. Point A cannot move in the direction of a string. If it does not move in the direction of a string, so total acceleration along the direction of a string has to be 0. So now let us see what are the acceleration of point A have. So so this rod has acceleration ax in this direction. So point A also have acceleration in the direction ax, because now rod also have acceleration in downward direction. So this will also have a downward acceleration a by. Are you getting? Now this rod is rotating towards this with angular acceleration alpha. So this point will have r alpha acceleration in the perpendicular direction, because this is also moving in a circle. If it is moving in a circle, this will have angular acceleration r alpha, and r is nothing but L by 2. So L by 2 into alpha. Are you getting? So this is the acceleration it will have. Now this angle is theta. So what is the x component? So in this direction you have ax cos theta, L by 2 alpha sin theta. So what is the total acceleration in this direction? That is ax cos theta plus L by 2 alpha sin theta. Because this is theta, then this is 90 minus theta, L by 2 alpha sin theta. Now this has to be equal with this component. So this is a by. Now this is theta, this is 90 minus theta. So this angle is what? So this angle is theta, this angle is 90 minus theta, this angle is theta, then this angle is 90 minus theta. You can check yourself. This angle is 90 minus theta. So if this 90 minus theta, so this component will become a by cos 90 minus theta, that is equals to sin theta. So this is equation number 4. Now the everything we have, now we need solution only. So how can we solve? That is the only issue we have. So let us say the solution of this equation. What we can do is, we have Ax from this equation. I can plug the value of Ax from this equation. So I have equation here. So Ax cos theta, let me write again. So I think you have copied this one. So I can copy this again. So I have final equation Ax cos theta plus L by 2 sin alpha, L by 2 alpha into sin theta. This is equals to A by sin theta. Are you getting? Now if I plug the value of Ax, A by and alpha, I will get the result. Let us wait for some time so that you can copy this thing if you have not copied. Okay, let us plug the value of Ax, alpha and Ay, we will get the result. So what is Ax? Ax is nothing but t cos theta by m. So Ax is t cos theta by m. So this will become t cos theta and cos theta. This will become t cos square theta by m plus L by 2. What is alpha? You see alpha you can find here. So 6. So this 2 to go 6 you will have. So 6t sin theta. And LL also goes, so we will have 60 sin theta by LM. Are you getting? So we will have 60 sin theta, because 2 and 12 cancel out, so we will have 6. So 6 goes this side, so we will have 60 sin theta. LL goes, so we will have L in the denominator, and M is there by M. So this is your alpha into sin theta. So this will become sin theta. Let me write sin theta so that you don't have any confusion. So this is sin theta. Are you getting? 60 sin theta you can get from here. So this 12 goes this side. So 6 t sin theta. M comes in the denominator. LL goes. So L also comes in the denominator. Is equals to A by. What is the A by? A by is nothing but mg minus t sin theta by m. Mg minus t sin theta by m. So this is your A by. Are you getting? And A by sin theta, so I have sin theta here. Now you see mass always cancels out, so you have only simply t cos square theta here plus this mass L goes out, so mass everywhere goes, this mass goes. Now in this case L also goes, so you will have 3t sin square theta, so plus 3t sin square theta. This is equals to mg sin square theta, mg sin theta minus t sin square theta. If you take this t sin square theta this side, so we will have t sin square theta plus cos square theta 1. So t plus 3t sin square theta. It's simply mg sin theta. Now from here you can write, so if you take t common, so you will have t 1 plus 3 sin square theta is equals to mg sin theta. So now things are easy. So t is nothing but mg sin theta by 1 plus 3 sin square theta. I think some of you have already got this result. So this is the tension. Are you getting? So mg sin theta by 1 plus 3 sin square theta. Let us copy this one and then we'll go for the next one. So what we have done is, we have written the three equation of motion. That is the motion of equation of motion in x direction, in y direction, and we have written one equation for rotation. That is the torque is equals to I alpha. And the third important equation we have, that is from constraint. And what is the constraint in this problem we have? We have constraint that the length of a string cannot change in the direction of a string. Why? Because if it changes, either it can break the string or it can slack the string. So we have said the string, because the time is so small, it cannot break the string or it cannot slack the string. So keeping the string neither breaking and nor slacked, I have a strain condition, that is the in the direction of a string, the total acceleration has to be 0. That is the constraint equation. You will have the same kind of equation in many problems where the constraint will be in the direction of a string, the total is 0. You will have same kind of concept in many problem also. You have to apply the same kind of constraint. Okay, we'll go for the next problem. I think all of you have copied.